Download this code from codegive.com, link in the description below. OK, let's dive into the concept of don't break the camera control button and how to achieve that using code, along with best practices and potential challenges. The core idea is to disable or otherwise prevent the user from accidentally triggering a camera control, like snapping a photo or starting a video recording, repeatedly or unintentionally in ways that can be detrimental to the user experience or cause issues. Understanding the problem ***. Imagine a scenario. Accidental taps ***. A user is trying to focus the camera, and accidentally taps the capture button multiple times in rapid succession. This can lead to a burst of unwanted photos. Slow processing ***. Taking a high-resolution photo or processing a video can take time. If the user can repeatedly trigger the capture button during this processing, it can overwhelm the system, lead to crashes, corrupted files, or a generally unresponsive app. Network requests ***. Some camera actions might involve sending images to a server. Repeated accidental taps can flood the network with unnecessary requests, consuming bandwidth, and potentially costing the user money. UI issues ***. Repeated calls to start and stop the camera might lead to UI glitches, inconsistent states, and a confusing experience. 2. Solution: debouncing and throttling techniques. The key to preventing these issues lies in employing debouncing and throttling techniques. Let's define what these are. Debouncing Debouncing ensures that a function is only called after a certain amount of time has passed since the last triggering event. It's like saying, ignore any rapid taps within the next X milliseconds. This is useful for events that might fire rapidly in bursts, like a button click. Throttling Throttling ensures that a function is only called at most once within a specified time period. It limits the rate at which a function is executed. It's like saying, allow this function to run, but only once every X milliseconds. This is useful when you want to avoid overwhelming resources with frequent updates. 3. Implementation with code examples: JavaScript/React, Swift, Kotlin/Android. We'll illustrate how to implement both debouncing and throttling in a few popular programming languages, focusing on disabling the button or preventing the camera action from being invoked too frequently. A JavaScript/React example: debouncing. Explanation ***. 1. UseState ***. We use UseState to track whether a picture is currently being processed. Processing is a boolean that controls whether the button is disabled. 2. UseRef UseRef is used to get a direct reference to the button element so we can disable/enable it. 3. Debounce function ***. This is a standard debouncing implementation. It takes a function and a delay as input. It returns a new function that, when called, will only execute the original function after the delay has passed without any further calls. 4. Take picture function ***. This function simulates taking a picture. You would replace the set timeout with your actual camera API calls. It sets processing to true, disables the button, simulates the processing time, and then sets processing to false and enables the button. 5. Debounced take picture ***. We use useCallback to memoize the debounced function. This is important for performance, especially if the component re-renders frequently. 6. Button click handler ***. The onClick handler of the button is set to the debounced take picture function. 7. Button state ***. The button's text changes to processing while a picture is being taken, and the button is disabled. B. JavaScript/React example: throttling. Explanation ***. 1. The main difference is the throttle function. It takes a function and a time limit as input. 2. When the returned function is called, it checks if inThrottle is false. If it's false, it immediately executes the original function and sets in throttle to true. 3. After the limit time, 500 milliseconds in this example, in throttle is set back to false, allowing the function to be called again. 4. This ensures that the take picture function is called at most once every 500 milliseconds. Choosing between debouncing and throttling asterisk. Asterisk debouncing asterisk use when you want to wait for a pause in the input before executing the function. Good for preventing accidental double taps. Asterisk throttling asterisk use when you want to limit the rate at which the function is executed, even if the input is continuous. Good for preventing overloading the system with frequent requests. Be Swift, iOS, example, debouncing. Explanation asterisk. 1 is processing asterisk keeps track of whether a capture is in progress. 2 debounce function asterisk this function returns a closure that encapsulates the debouncing logic. It uses dispatch work item and dispatch queue.async after to schedule the action after a delay. If the debounced function is called again before the delay expires, the previous work item is cancelled. 3 debounce take picture asterisk this lazy var is the actual debounce function. We are calling the debounce function and providing the function we want to run, take picture. 4 take picture function asterisk this function is where your actual camera logic would go. We disable the button to prevent further taps, simulate the capture process, and then re-enable the button. See Kotlin/Android example, throttling. Explanation asterisk. 1 is processing asterisk flags whether the camera is currently processing. 2 handler asterisk used to run code on the main thread after a delay. 3 throttle function asterisk this function encapsulates the throttling logic. It checks if the specified delay has passed since the last execution. 4 take picture function asterisk disables the button while simulating the camera capture, and then re-enables it after the delay. 4. Best practices and considerations asterisk asterisk. Asterisk user feedback asterisk provide visual feedback to the user when the button is disabled. Change the button text, example processing, show a spinner, or change the button's appearance. This makes it clear that the app is busy. Asterisk appropriate delay asterisk experiment with the delay time, example 500 milliseconds, 1000 milliseconds, to find a value that prevents accidental taps without feeling unresponsive to the user. Consider making the delay configurable. Asterisk error handling asterisk implement robust error handling in your camera logic. What happens if the camera fails to capture an image or if there's a network error? Make sure to gracefully handle these situations and provide informative error messages to the user. Asterisk accessibility asterisk make sure that the debouncing/throttling doesn't negatively impact accessibility. Users with disabilities may rely on assistive technologies, and these technologies may interact with the camera button in different ways. Test with accessibility tools to ensure a good user experience. Asterisk long-running tasks asterisk if the camera operation involves long-running tasks, example uploading images to a server, consider using background tasks or asynchronous operations to avoid blocking the UI thread. Display a progress indicator to keep the user informed. Asterisk platform-specific APIs asterisk explore platform-specific APIs that might provide built-in debouncing or throttling functionality. For example, Android has View.onClick Listener which can be combined with a custom implementation of throttling. Asterisk state management asterisk use a proper state management system, Redux, Context API, VOX, etc. depending on your framework, to manage the is processing flag in a more centralized and predictable way, especially in larger applications. V advanced techniques asterisk. Asterisk reactive programming, RX Java, RX Swift, RxJS reactive programming libraries provide built-in operators for debouncing and throttling. This can often lead to more concise and elegant code. Asterisk example, RxJS. Asterisk custom hooks. React. You can create custom React hooks to encapsulate the debouncing or throttling logic, making it reusable across multiple components. Asterisk example, debounce hook. Then, in your component. 6. Summary asterisk asterisk. By implementing debouncing or throttling, you can significantly improve the user experience of your camera application, prevent unwanted side effects, and avoid overloading the system. Remember to provide clear feedback to the user when the button is disabled, choose an appropriate delay time, and handle errors gracefully. Choose the debouncing/throttling that is most appropriate for your specific needs. Consider using reactive programming libraries or custom hooks to simplify your code and make it more reusable. Always test thoroughly to ensure that your changes don't negatively impact accessibility.